energy in general was initially set, there was no kind of intermediate steps. And for a time it looked as if we would just be waiting until 2019 and then a miracle would happen. But now actually in the meantime intermediate targets are being developed. I don't know them all, but they are being developed for fuel ethanol. For example, there's a target that I think within 2 or 3 years we should be at 575, and I believe they're talking about another intermediate target. In general, I'd say that the European kind of public, which influences greatly the European politicians, are very much in favor of second generation. And somehow they got it all wrong with the first generation. Unfortunately, it seems like sometimes almost a lost battle in Europe to talk about first generation. Second generation I think, would have an easy way into the European market.
Okay. Muito obrigado, Steen. Thank you very much, Steen. Pessoal, vamos partir então para a segunda apresentação. A apresentação vai ser do Ricardo Madureira da CanaVialis. As perguntas vão ir no final, tá? Nós vamos fazer no final. Se alguém tiver mais alguma pergunta por escrito, por favor, levante a mão, nós vamos coletá-las. No final, fazer uma mesa redonda com todas as perguntas dos participantes, tá, ok? Até para poder controlar melhor o tempo que a gente tem disponível. A CanaVialis e a Lelix, para quem não conhece, foram fundadas em 2002 como parte da área de novos negócios da Votorantim. Elas são dedicadas ao desenvolvimento de pesquisas na área de melhoramento genético de várias culturas, entre elas eucalipto, laranja e cana-de-açúcar. Sendo que em 2008, essas empresas foram compradas pela multinacional Monsanto e se destaca para sua atuação na área de biotecnologia, né? Sediada em Campinas, no estado de São Paulo, a CanaVialis tem atuação no setor sucroalcooleiro, oferecendo serviços, produtos e consultoria na melhoria da produtividade das lavouras de cana-de-açúcar, né? O representante da CanaVialis é o Ricardo Madureira. O Ricardo é presidente da CanaVialis desde agosto de 2005. Antes da CanaVialis, ele exercia a posição de diretor de operações da Votorantim Novos Negócios, onde participou do desenvolvimento do plano de negócios dessas empresas. Antes da Votorantim, o Ricardo exerceu várias posições executivas da Ambev. Ele é engenheiro químico com especialização em tecnologia cervejeira pelo CBO Institute of Technology de Chicago, tem um MBA pela Fundação Del Cabral e é formado pela OPM da Harvard Business School. Como vocês podem ver, o Ricardo tem uma carreira longa com etanol. Com vocês, o Ricardo.
Okay, thanks, Nilson. Boa tarde a todos. Good afternoon. Okay. It's a great pleasure to be here today. I'd like to say thanks again for the opportunity to be here and the opportunity to share with you what we have been doing in our companies. Actually, we have two companies. One is CanaVialis. The German planting company, where we develop new varieties of sugarcane and also agricultural services. And the other is Lelix, that is a biotech company that we have a well-developed pipeline of gene discovery, and we develop biotechnology focused on sugarcane. This is a summary of our history from ground up to being global as part of Monsanto. The two companies were established in 2002 and 2003, and those are some of the key milestones of our history. As you can see, we have been working with Monsanto since 2007, when we started a collaboration to develop a BT Roundup Red sugarcane. And the two companies were acquired last year in December by Monsanto. You may be familiar with Monsanto. Monsanto is a leader, a global leader in the field of agricultural technology. Actually, Monsanto works with different crops, mainly corn, soybean, cotton, and vegetables. And now, after the acquisition of our companies, works with sugarcane as well. And the beauty of being part of Monsanto is the opportunity that we have today to put what we have been doing in sugarcane, our expertise in sugarcane, together with tremendous technology that Monsanto has been developed and actually commercializing sugar in other crops, like, as I said, cotton and soybean. For the purpose of this presentation today, I have broken the whole production chain of biofuel down into 3 main blocks. The first block is the biomass production that is related to the agriculture side. The second block is biomass breakdown that is related to physical actions, chemical reactions, enzymatic reactions that breaks the biomass down into sugars, releasing the sugars in the biomass. And the last slide, the last block there, is refining products, that is fermentation process that transforms the sugar into the biofuel, into ethanol, and other chemical compounds. I just wrote down there some technology related with each one of the blocks, but my main focus today is on the agriculture side. As I said, we are agricultural technology companies, and as agricultural technology company, I like to reinforce the importance of the biomass production throughout the chain. And also, I would like to cover with you some of the technologies that we have been developing focused on sugarcane and other energy crops. So, okay, this is a slide that shows the operational cost of ethanol from sugarcane. And as you can see, the bar on the left, most part of the cost comes from the agricultural side, around 70% of the cost. So it's quite important to have a well-efficient production of biomass, of sugar, in order to have a well-efficient production of ethanol by the end of the day. And I believe that it wouldn't change. It continue to be an important role. Biomass and sugar will continue to play an important role in this whole chain, no matter if it is a second-generation ethanol or advanced biorefineries. And thinking of biomass and sugar, there are some important characteristics that the biomass and the sugarcane or biomass or sugar production must accomplish in order to help the whole chain. And for the purpose of this presentation today, I have grouped those characteristics into 4 pillars. Actually, the first picture there, the first picture there is local availability. It means that you're not supposed to transport biomass from a long distance from the production side to the industrial side. Therefore, varied adaptability, good agronomic performance in multiple locations is a must. The second thing is production and quality. You need a high yield, but homogeneity. You need to supply a continuous source of biomass with a standard quality to the industrial side. The third thing is sustainability. You need to have a high yield, but with less water, less nutrients. And the fourth thing there is the traits, actually biotech traits, that could change the composition of cellulose, lignin, or even sugars in order to improve the industrial side. And as I said, I will cover some of the technologies that we have been developing, focus on different characteristics there. But before that, I'd like to invest with you some of the time talking about sugarcane. Sugarcane is a tremendous crop. And there is nothing like sugarcane to produce sugar and biomass in the tropics. And the sugarcanes that we plant today is a hybrid between 2 species. One is Saccharis officinarum, that is on your left there in the picture. This is the cane that the Portuguese first brought to Brazil at the beginning of the colonial period. It's a very juicy, very sweet sugar cane, but with low productivity. And on your right, you can see a grass that is a Saccharis spontaneum. That is a very tough grass, resistant to disease. And the breeders, they have been breeding those 2 species in order to come up with the modern varieties. And actually, those are the varieties that are planted here in Brazil, Australia, South Africa, India, USA. And this high complex genome, together with biotechnology and breeding, will allow sugarcane to grow in well-adjusted conditions and regions. And this is pretty much what we have been doing here in Brazil. part of our breeding program is focused on new agriculture frontiers in Brazil. And as you can see, there are some graphs that just to illustrate. And those graphics show the comparison between the blue bars, that is the variety that were developed in traditional areas for sugarcane, that is now planted in commercial fields in these agricultural frontiers. And the yellow bar shows some varieties that we have been developed inside locally. So there's a huge opportunity to increase the productivity. In this case here, sucrose per acre or per hectare in this area by developing locally this variety. Well, and biotechnology can also play an important role in this field. Those are two technologies that we have been developing. The first one on the bottom is the BT Roundup Red technology. Actually, it is a technology that protects the cane against borer. Borer is the most important pest in Brazil, sugarcane. And the herbicide as well protects against glyphosate herbicide. This is a technology that Monsanto has already developed and commercialized with corn and soybean, and a very well-known technology for Monsanto, and now we are developing for sugarcane. On the bottom, you have a technology, a very new technology for us, is drought tolerance. We have discovered and patented a gene that can improve the resistance to drought tolerance for sugarcane. We are at the very beginning of this process in the gene discovery phase, but Monsanto has more developed technology for corn that is in the final stage, and that now we are analyzing the opportunity to bring to sugarcane as well. Okay, now I would like to focus more in biomass, to focus more in cellulose production. Sugarcane, we have the opportunity to develop a cane, not with sugar, but with more cellulose or more biomass. So part of our breeding is focused to develop an energy cane or a fiber cane. The name is not certain yet, but the idea is to develop a cane with more biomass. And as you can see in the picture, it's a pretty different plant. It has many more leaves and many more stalks. And the most important thing is on the graphs on the right side. As you can see, on the far right, the bar is a conventional variety, and the other are varieties that we have been developing. And the green part of the bar is the dry matter or the cellulose content of those varieties. And as you can see, there are varieties with more than the double of the biomass if you compare with the conventional variety that we have in the market today. So there is a huge opportunity to increase the biomass in this case as well. It is also important to the second generation ethanol, but it can be also important to generate energy, to improve the amount of biomass to produce the bioelectricity. Well, okay. Well, so in this case here, the biomass, biotechnology can also play an important role. There's other two technologies that we have been developing. We have also discovered and patented some genes that increase the cellulose production. The first one is a gene that seems to us that works in the photosynthetic production of the cane. It's new for us, so we understand better how these genes works. And on the bottom is a gene that can increase the deposition of cellulose inside of the cell walls. As you can see on the left is a conventional tissue with a conventional cell wall. And on your right, you can see a very thicker cell wall full of cellulose. It means that at the end of the day, you have more cellulose for the same area. You increase the amount